Hello class. You are okay, Millie? You seem very quiet. Why? Could you answer us this question? If it defeats you, you send it to another person. You see that? Send it to another. Now the question is simple. If there are 7 people in a place, not so? And they begin shaking hands. You shake once with somebody else. How many handshakes will they be? Seven people in a place shake hands, and each shakes once with another person. I'm seeing many hands are risen up. We start. You are ready, Mile? You are not ready. Let us have pressures. How many hands will shake? How handshakes will they be when you count?
I think it is 14.
14 handshakes. I think you know how to shake hands, not so? How many? 49 hands will exchange. Okay, patience, how many? The question goes, for 7 people in a place, and before they interact, they first shake hands. No, a handshake, you know a handshake. Yes. And each shakes a hand once with somebody else. How many handshakes will they be? 6. 6 handshakes? Not really. 2 handshakes? 7 people begin to shake hands. You shake your neighbor, you go and shake, and another one shakes.
Teacher, I say 6. So for me, remaining
49. I'm going to give you an assignment like this. Let the 70 people be A, B, C, D. And what? A, B, C, D, E. How many are those? F, G. Now let A shake hands. And it goes. Then do the same for B. Total will be? Will it be 49? Are you sure?
Maybe.
You'll because B will now not shake with A, but will now. Then C will 42 hands.
Okay, teacher.
That's your assignment, not so?
Why? How?
I've shown you to join, not so? Join and count.
Use something.
No. You can use any mathematical method, but I wanted somebody who can work with the head very fast. Okay, you can start with 3. You try to shake hands when you are 3 and see how many hands will they be. Then work from there. Now, without wasting a lot of time, since your brains are now working, we go to topic what? 12, called reflection. People are still counting. Please leave hands alone. You'll count later. Not. Make sure they are 21. But you don't shake somebody else again. You shake once. Now, our subtopics here. We are going to review lines of symmetry. We shall review lines of symmetry. Yes. Then now we go to reflection in in a plane mirror or the mirror line. Then reflections in the Cartesian plane. But there is something we shall pick from here called congruence from here in the mirror. Then finally we see reflection in the Cartesian plane or XY coordinates. Cartesian plane. Now let us right away start with lines of symmetry. Lines of symmetry. I hope you recall how to get a line of symmetry of any plane shape. Do you remember that? Somebody can remind us how will I find the line of symmetry of, say, this paper? This paper. How many can recall we discussed it under polygons in angles? How would you find the line of symmetry of these? How do you establish that? You can demonstrate to us? Yes, you can demonstrate from there.
When we said the two lines of folding symmetry are rectangle halves, first of all, this is a rectangular paper. So if we fold it like this, this side and this side are equal. And still when we fold it like this, this side and this side are still equal.
What if you fold it diagonally? Is there a line of symmetry? Why?
Because this side, they all don't fall on each other. This one falls.
Say it again.
They all don't fall maybe on each other because this one falls separately and also this one falls separately.
That means they must fall exactly on the other. Yeah, thank you. Okay, that means to establish the line of symmetry, carry out what we call folding. When we fold and a part falls exactly on the other part, then there is the line of symmetry. Okay, we can review some here. The polygon and its line of symmetry. You've told us that a rectangle has how many? Two lines of symmetry. Then a square. Square would arrive at 4. Square. Then I will need you to find out on a kite. A rhombus has how many? Parallelogram has how many? Rhombus would have? Rhombus has 1. And you are very, very sure. Where can it be folded? Here. What over here? You can't fold this and it falls on that.
It can. Because they are all equal.
Then folding like this. Therefore it has how many? But you had you deceived us or not?
I had not deceived.
You are not deceived.
I was just saying I didn't deceive.
Okay. Parallelogram would have how many?
1.
Where would it be? Let's try to see. How many lines of symmetry will this shape have, a parallelogram? Here there are two lines of symmetry. Square has, kite will have, along here, one. Then parallelogram,
0.
Why 0? If you fold it here, it folds here. If you fold it this one folds on. No line of symmetry. You can find out many equilateral, triangle. I hope you are convinced. How many? Equilateral double. What of here? And 3. Yeah, that's about, now the assignment I'll need you to do is you'll write down all the letters of alphabet and find out those with the lines of symmetry. Which letters of alphabet have lines of symmetry? I would like you to work out the lines of symmetry for each. Work out lines of symmetry for all letters of alphabet. Like if you are working out A, you would find out how many lines it have.
1.
I think you can work out B. B would have
1.
Why not here? They can't. C would have?
None.
C would have none?
Someone.
Where? Here?
No,
Here. What of here? Nothing? Then letter D?
Horizontal.
Like this?
Yes.
That means you'll go and work out those lines of symmetry for all those letters. It's what? Chibina. Now, I hope now you capture that underlines. I want now to drop to, we finished reviewing this, and I want us to review what we discuss as reflection. Reflection. And I will ask you to look at yourself. Girls, you like very much looking at yourself in mirrors. I don't know what's the problem. Even some boys look themselves in a mirror. Almost all. It is good to look yourself in a mirror, but now boys don't normally find it natural in them. Like me, I have forgotten, I don't know how many days I haven't ever looked in the mirror. It's natural, not so? But for you, you looked at yourself in the morning. Did you? You also did not.
We don't have a mirror.
It's very bad. Now, when you look at yourself in a mirror, what happens to you? Comment on yourself in a mirror. If I ask you that, do you know how you look yourself? Do you know how you look?
Yes.
Right now?
Yes.
Or you want to look at yourself with eyes? That's now. If you look at yourself in a plain mirror, I believe you looked at yourself today. Now, how do you look in a plain mirror? Do you look, if we say that you have gray hair. Will you believe it?
Yeah. Because the images are real.
No, in the case right now I say you have gray hair and you look at yourself in a mirror and what will you see? Let me ask Mira. Mira, do you have gray hair which I'm seeing on your head? You don't have, not so? That means that a mirror will give you exactly what you are, not so? Now, let us start with reflection in a plane mirror, then we discuss that reflection in a plane mirror. Take an example. If we say reflect letter E in a plane mirror, if this was our mirror, how would the letter E look?
Inverted.
Look inverted. Look inverted. How will such look in a plane mirror? Can somebody work out these shapes for us? Then I will also require, yes, just 3 people. One will work out the word eat. The word eat in a plane mirror, how will it look like? Eat. Yes, come and work out letter E, Precious, in that order.
Like for easy working it out, maybe we can put there a line and we do this. Not like this. Like this. So I don't know how to write your E.
You don't know how to write my E.
Yes.
Okay, thank you. Grace, come and take over the
Teacher, me and patients have agreed about
Just work out the line.
So since this is a plain mirror, so we shall start from the ending letter, which is letter T, then F, and then when it comes to E, it won't be facing this side, it will be facing this side.
Okay, come and work out the last one. And you'd also, after that, to tell us how you appear in a plane mirror. I think that's you are you convinced?
No, I'm not convinced with her. reflection of letter A.
Yes.
It's not the same. It's used the same as it.
But at least it's
Look at the it. Look at the it.
Should it have been vertical?
no, just like how
Slanting.
it's crooked.
It's just straight.
Okay, but is the distance as measured correct?
No.
Fine.
Are you the same distance from the mirror with your image? If you look at yourself in the mirror, is the image the same distance as you are from the mirror? Whenever you see yourself in a mirror, if you put your face here, where does the image put? If you put a face on this paper, on the mirror, will the image be here? Or you knock each other? When you move it, does the image move? Oh, okay. Do you believe that the image and the object is the same distance? Okay, let us discuss properties of images that have been formed in a what? In the plane mirror. Now this is the object, this is its reflection or image. We call it an image. Okay, what are the properties? Start listing. Yes, Grace, I start with you.
The object and image distance are the same.
Yes, the object. Now this is properties of reflection in a plane mirror. Object and its image distances are the same, not so? Okay, that's great. Next, what do you observe also?
Object and image are the same.
Object, what in terms of?
Same.
Object size and shape is the same as that of
The image.
its image. Now this one, this being the same, two things when they are same, we say they are what? Congruent. That's what will help us discuss congruence. The similarity in size, shape, in every form, the angles are the same. In case it has angles, those are said to be congruent shapes. What else? Yes, Precious. The image is real. What do you mean by real? The image is real.
It's not like someone can make the photo.
It's real.
It's really implicated, like it's exactly
What's
like
a photo here is what is real. It's real.
Isn't it this?
Okay, it is inverted.
Is it real? To be real, I think reality means if this paper is real, I can touch it and feel it, not so? Isn't this paper real?
Another property.
Hmm.
It is inverted, just like you see that word is the other side, this side is turned upside down.
The image is laterally inverted. What do you mean? The left hand side appears as the right. Yes,
Should we also put that
patience.
property?
Put them.
There is a reflection ray and the incident ray.
You want to bring in the physics?
You say it's okay.
It's you said it was okay.
Yes,
It is true there is a reflection of light, but now things will become much more deeper than we think. If we involve in now, I made a mistake to say add science also. That would be hard. He said the image is real, but here we said the image is what? Virtual. To be virtual is to, we think you are there, but when we touch you, you are not. Like if you go and touch yourself in a plain mirror, can you pick yourself and see and have two people of yourself? Maybe if you do much research, you'll never get for us a second person of yourself from a mirror. It's virtual, not so. To be virtual is to be seen, but you don't actually, you are not tangible. We say you cannot be formed on the somewhere. You can't be formed. Yeah, it's virtual. That the object and the image are congruent, we've seen that. I think we exhausted the properties. More others? Nothing, not so? Yeah. Now, we want to start reflecting these shapes. We've reflected the numbers in plane mirrors and some other few shapes. But we want to reflect now in the Cartesian what? Plane. But before that, let us discuss that term congruence first. Congruence. That for two shapes to be congruent, it means they are the same in size, shape, and angles. You measure this one's angles are the same. Congruent shapes have same size, shape, and angles. Yes. Now I will need people we discuss this. When we saw now there is this one before we continue. Types of congruence. I think we can see that. When we saw things in the... Let me ask you to look at these two things. This angle is 60. This angle is 30. This angle is 40. So that this angle is 80. This angle is 60. This angle is 80. This angle is 40. A, B. Then I have another set here. I hope somebody sees that. 60, 60. Now, if you look at those shapes, this one faces in the same direction as the, not so. But if you look at C and D are facing in opposite, you see. But they are the same in size and shapes. That means they are congruent. These are directly congruent, these are oppositely congruent. That direct congruent is when the shapes face exactly in the same direction. Whereas in opposite is when they face in the opposite, or they face in the reverse direction from each other. Direct congruence is a case where two shapes face in the same direction, whereas in the opposite congruence, shapes face in the opposite or reverse directions from each other. Now, I would like somebody to we just have like 1 or 2 examples here. Yeah. Now this number people should do. It means you must draw exactly similar size. Be careful. And if these shapes are congruent, then what is the value of x? X would be 80. Y would be centimeters. X goes. This is just what? An error. An error. That is 30, yeah. 30. How come? But you would have told us that, so you have made a what? Of saying such. Okay, let us continue to reflection in the XY plane. Or the XY plane is called the Cartesian what? You are set, not so? Let us discuss that as our last version of reflection, and that's a reflection in the Cartesian what? Plane. Now, for us to reflect Cartesian plane, we need what we call, of course, we have been reflecting using a mirror, but now after plotting, we don't have a mirror there. We must now create what we call mirror lines through which we can use them to reflect. That means a reflection in XY plane involves use of what we call mirror lines, because here we don't have a mirror. And let me just give some people a clue. We dealt with the equations of lines in topic 11, and before, let's just look at several mirror lines here. If this is the y-axis, clear? This is the x-axis, not so? Now, if we plotted this, you need to listen very well, because now we are going to start with our reflections, but I'm just giving a clue here of how you find out a mirror line. Now, if a line goes through, if you have a horizontal line going through a y value, this point we shall call it y is equal to. That means horizontal lines are y lines. Y is equal to? Horizontal lines are y lines. Whereas if you cut through x, then it will be a mirror called x line, which is x is equal to 1. Clear? If you go through here, x will equal to. These are all mirror lines. That means we are going to reflect our objects in these lines that I'm talking about. They will act as our mirrors. Okay, with mirror lines, e.g. x is equal to 2. 2 twice negative 1, x is 0. X is equal to 0 is normally there you are. I don't know whether somebody can not see that. Because your x values, your x line, all x lines are what? Are vertical, because they cut through the x-axis. That means x will be 0 will be the vertical y what? Axis. Clear? Now we have other line like this, etc. Hope you are set, not so? You can put that down. I'm waiting for you. Now the question is specific, 1 centimeter, 1 unit. That means 1 box, 1, 1. Now you should be plotting. Ensure you use balance it. Patience, I think you are going to label y-axis and the x-axis. Make sure you are using 1 centimeter, not 2, because we are going to reflect and you need enough space. Already. Okay, we plot it, not so? That's negative 1, 1. Negative 1, 1 is right here. Call that point A. Then negative 2, 1. Call that point B. Negative 2, 3. Then negative 1, 3. Join with the ruler to form a rectangle, yes. To form a rectangle. Now, I'm waiting for you. Now it is easy to reflect in the x-axis and y-axis. Another line than that. Of course, when you are reflecting in the x-axis, you just count how many squares to the x-axis from that coordinate. This and this is direct, but here we shall use the concept of construction, or using another line than the x-axis. We shall use this combination to just move up to where we want, or we use construction, any will work. But let us start with x-axis and y. We just count squares, like now let me reflect first in the y-axis. I look at how many squares is A up to here. 1. I count the same this way. Then that will be my image A prime. Then B is located two squares. That means B prime. Then locate D. Just count squares to the reflection line. Then here will be C prime. Get a ruler. Count squares. D is 1 up to here. Then C is 1, 2, 1, 2. Then have that one formed. it is easy to reflect in the x and y axis by mere counting squares to that line. Let us reflect in the x-axis. When we reflect, count again. These are 1, 1. That means a double. Now you use different symbols. Then this is also B double. Then this one is 1. Your graph paper shows it clearly. 1, 2, 3. Therefore 1, 2, 3. And I would have the other one.
Excuse me.
Very much excused.
Those letters have to look the other side.
No, labeling does not what? Is not affected. The labels won't matter. Is that right? You just change that. You just change them. Here we use the one prime. Here you're using 2 what? 2 primes to mean it's a second image using another reflection. We can ask you to state these coordinates. Grace, why are you shaking the head?
It's not a reflection, it's a funny image.
Mine? I thought you were saying even yours, but you are only saying mine. Now, let me go to this other lines, which is not the x-axis or y-axis. Remember, y-axis can be told to you to be x is equal to, and this is this one. But let me look at this one here. Are we right? Are you through? I want to remove then handle this line, Roman 3. Now, when you are handling y line, now we are using line this. When you're handling that line, you first have to get coordinates and plot this line, because this line is not obvious here. It's only the x-axis and y which are obvious. This one you have to get a few coordinates. Just it y enough, x and any values of x you state. You can say 0, 1 or 1, 2.
How about negative 1, 0?
Yes. I think if this is 0, this is also 0. If it's 1, this is also. Yes. That means plot 0, 0 and 1. See where that mirror line is first. It's that means plot this mirror line first before you can. You are plotting another graph. This will distribute plot on the same. That means our mirror is there. Have you said that right? Mira, are you okay? Label that reflection line, y is equal to x. Now look here. When we want to find where we can trace this the other side, we can use construction. We construct a perpendicular from here to meet this one. You understand? The concept of constructing a perpendicular from a point, you recall? You stand here and make arcs. You recall that?
Yes.
Yeah. But that one would be a bit tasking, but we can as well play it using this. You can try that method of perpendicular construction first. Then I'll rub that one. That means we stand where? Stand there. Not so? sorry, stand there, then make arcs. Make an arc here, then make an arc, but make sure the arcs are just light enough, then construct something here, just very brief arcs there. Then get down your that means join here with dotted. Now you now just use your compass to trace this and transfer it where? That means using your compass, measure this and see how much it is, then you can locate. That means here, then it will be, I think you understand. Then this is point A, what? A image. Repeat the same for this. Draw a perpendicular from here. You see, that means stand here. Again, make arcs, and this compass will move a bit. That means stand here. Make arcs. Make arc here. Make arc there. Then stand here. Make. Not so? Yeah. Then now you do what? You construct your perpendicular through here. That means dotted up to behind there. Then you measure this distance. You measure this distance to the mirror as using your what? Using your divider, or divider would be accurate in case you add it, because it is very, very pointed. Then this. That means this is point D image. Do the same for this. That means stand here, make arcs on the mirror. Let me reduce it so that I don't want to cut where others are. That's why I'm widening it. Then see, there are many lines there now. They will confuse you. That means follow very well, very well. Now yeah. Then also measure up to the mirror. That each time you construct a perpendicular from the point. Then which point is this? CC image. Yeah. Then stand here. Are we there? Stand here. Also make what? Arcs. Make arc, and then sorry. Then it draw also. Hope I'm accurate. Hopefully that I'm accurate. Yeah. Then also measure this distance and using your then this is my B image. This, where is A? A is here. Then you now form I hope I'm very accurate. But make sure you are more accurate than me, because my things might not be very accurate like yours. Yeah, that's the reflected thing. But I'm going to show you another method which has no construction. To repeat, now we can, because we said when I want the image of A, stand at A, you are using the concept of constructing a perpendicular bisector from a point to a line. We said to construct you have to stand at a point, draw arcs on the line you want, then stand at the arcs. You can reduce the compass a bit, then construct here, and also stand there and construct, then join through a straight. That's what we are doing to each point. Since I want to construct each perpendicular on the line, stand there, cut arcs on the line, stand at the arcs. Yeah.
And then measuring the distance.
Now, after constructing this perpendicular, you have to measure up to the line, then carry it this way. One now to show the one using a set square and a ruler. You'll practice many. I'm waiting for you as we prepare for you the activity of integration. Could we demonstrate the other one? Let us demonstrate to you the other one. Let me clear off this. Those who don't want to use the perpendicular constructions, I want to show you the one of using just your instruments in the set. Now when you are using your now make sure you write down the coordinates of that image. I want us now to go to attempting to use our instruments. Are you ready? Let me plot a negative 1, 1 is here. Then B is negative 2, 1. Then C is negative 2, 3. Then that is D. Join your shape very, very well here. Hope I'm slightly accurate, but the aim is to just show. Now I want you to look here. I'm not using instruments again. I'm not using constructions, but now we are going to place them in such a way that let me test the correct direction here. Now my mirror line is there. Yeah, you move, since this is at an angle of 90 to this, just move up to B, draw dotted, stop here, you will extend later, up to A, draw dotted, you will extend later, draw dotted. That means simply fix this. That right? Let me start. I'm going to start with what? With A. No, let me start here, not so. Now, all fine. Up to my mirror there, go to A. Go to C. Go to D. It is shifting. Then remove. Then continue the lines this side. Then get your compass, trace now the points. That means trace B, measure at B, up the mirror line, come this way. That's B, image. Trace A, That is a image. Trace C, mirror line is here. That means for C, I will have to extend a bit here. Then D, I'll also have to extend for D. No, D is right there. It means D, this is C. And you are through. Which one is easier? I brought it last. No, but why did you want to bring it first? You would have refused the other one. Sorry. But the task with this one is look for, because these shapes will change, just look for mirror line, place this one depending, just sit one edge. Hope you understand. Sit one of these. Don't sit this. Sit this. And so whether it is turned the other way, always sit. Now I think that closes me down for reflection. More numbers, I'll give you reference books. You go and you can write down these coordinates, not so? Now we should stop there for reflections, and I request that you are going to find the revision work in our new curriculum book called the Learner's Book. There is an exercise there, and also there is an exercise in a book called the School Mathematics. That means you'll visit this book, the old curriculum book, for more elaborations on this. It has tried to explain these things very well. You'll visit that. Then you also visit our new curriculum book that has the new curriculum material for Learner's Book. It has exercise. Yeah. Now, let me give you this activity of integration. Then we shall meet in topic 13. You can write it down. It says here. One of your relatives wants to make a barber shop. One of your relatives wants to make a barber shop / hairdresser. He approaches you for help. He approaches you for help. As a senior 1 graduate, draw a plan of how, as a senior 1 graduate, draw a plan of how you can help your relative, make his or her barber shop be up to date. Support, semicolon, interior plan of the shop. Support is interior plan of the shop. Interior plan of the shop is support. Task. Advise the barber to make sure the customers. Advise the barber to make sure the customers can view themselves. The customers can view themselves with their images not distorted. Can view themselves with their images not distorted. Resource, not distorted, resource, knowledge of reflection. Yeah, now we've gone through reflection. We reviewed the lines of symmetry. We saw how you can reflect yourself in a plane mirror, and we saw the properties that you look congruent. And we saw that in a plane mirror you look oppositely what? Congruent. You don't look direct because you face each other. Then we have finished up with now reflection in the XY plane. Thank you. We meet in the next topic. That's topic 13.